The problem I'm going to be solving is Dan is gliding on his skateboard at 2 meters per second. He suddenly jumps backwards off the skateboard, kicking the skateboard forward at 6 meters per second. Dan's mass is 50 kilograms, and the skateboard's mass is 7 kilograms. So to set up this problem, I first set up a visual representation, figure 1. So the problem first describes that Dan is on the skateboard, moving at a velocity of 2 meters per second. So here I drew the system where the skateboard and Dan are both moving at the same velocity. And then in the second half of the problem, Dan is off of the skateboard and the skateboard is continuing to glide at 6 meters per second. So the question that I'm going to be answering is, how fast is Dan going as his feet hit the ground? So the equation that I'm going to be using is m1 times v1 equals m2 times v2 plus m3 times v3. So to define the variables that are represented here, m1 and v1 are the entire the system in the first situation where Dan is on the skateboard. So mass 1 is going to be the combined masses of both Dan and the skateboard, and velocity 1 is the initial velocity of 2 meters per second that was mentioned, and then m2 v2 is just the mass of Dan and his velocity, and then the mass of the skateboard and the indicated velocity of the skateboard, which is 6 meters per second. So according to the problem, we're going to be solving for Dan's velocity, which is v2. So we can rearrange this equation to solve for v2. In this case, the velocity is equal to m1 times v1 minus m3 times v3 all over the second mass, or the mass of just Dan. And so to solve, I plugged in the values. This is Dan's mass of 57 kilograms, or the mass of the combined skateboard and Dan, which is 57 kilograms, their initial velocity, which is 2 meters per second. And of course, the mass of just the skateboard and the velocity of the skateboard after Dan is off the skateboard, and then the mass of Dan. And so to solve, I got a velocity of 1.44 meters per second, and that is the velocity that Dan is going at as his feet hit the ground. So this problem primarily deals with momentum and using that to explain what is going on in collisions. So of course, the equation for momentum is going to be mass times velocity, which is why we can derive an equation like this, which describes the entire situation and the different parts of the system and what's going on. And I think the tricky part about this problem is figuring out which variables are applicable to which portion of the problem. I think that's definitely a bit tricky, figuring out which mass to write for M1 and so. Thank you.